This is prerequisites, P.4 polynomials. A couple of rules and some things to keep in order before we go through some examples. When you're adding and subtracting polynomials, you combine the coefficients of the like terms, but you keep the base or the variable the same as well as the exponent. When multiplying, you multiply the coefficients and you add the exponents. So the variable is going to stay as is. And when you're dividing, you divide the coefficients and you subtract the exponents. Okay, so let's see some examples here. We're simplifying the difference, and in this question, this is subtracting polynomials. First thing we need to do, we need to distribute the negative across everything inside the right side of the parentheses. So we're going to take the left half, 3x cubed plus 5x to the fourth plus 2. We're going to bring that down. And we're going to change all of the signs of the parentheses to the right. So it becomes negative 2x to the third, negative 7x to the fourth, positive 3, and negative 2x squared. At this point, we're going to want to combine the like terms. Okay, so I'm going to start with the highest exponent, and that's x to the fourth. So that's the highest degree. And I'm going to combine my x to the fourths. I have two of them. I have a positive 5 and a negative 7. When I combine that, I get negative 2. Okay, then I'm going to do the same thing with my next degree, which is x to the third. And there's two of those. There's 3 and there's negative 2. When that combines, we get 1x to the third. Okay, then we drop down to x squared, and there's only one of those, so we just leave it as negative 2x squared. And then we combine our constants. We have positive 2 and positive 3, and that becomes positive 5. We have now simplified it. We can't combine any more like, there are no more like terms, so we can't combine any further. So this is our answer. Our next example wants us to find the product. So in this question, we have to distribute. Just make sure when you're distributing a binomial across anything that you multiply first by the first term, in this case by 3m, and then by the second term, which is negative 6. Okay, so we're going to start with a 3m. When we multiply polynomials, remember you multiply the coefficient, you add the exponents. So 3m times m squared is 3m to the third. Remember, m is m to the 1. So if it doesn't have an exponent, it's always 1. So 3m to the third. 3m times 7m is 21m squared. 3m times negative 3 is negative 9m. Okay, then we multiply negative 6 by everything. So we get negative 6m squared minus 42m, right, plus 18. Now that we have distributed completely, we're going to simplify by combining like terms. We only have one m cubed, so that just remains 3m cubed. We have 2m squareds, that's 21 and negative 6. All right, we're going to combine those. And we're going to combine the negative 9m and negative 42m. There's only one 18, so that stays 18. And we get 3m cubed plus 15m squared minus 51m plus 18. Okay, and that's our answer there, since we can't simplify any further. Our next example is actually a special case. It's still multiplying polynomials. This time it's 4k plus 1 quantity squared. What squared means is times itself, so what we can rewrite this as is 4k plus 1 times 4k plus 1. And now we can just do the simple double distribution. 4k times 4k is 16k squared. 4k times 1 is 4k. 1 times 4k is 4k. And 1 times 1 is 1. Then we combine like terms. We have 4k and 4k, which makes 8k. So our answer is 16k squared plus 8k plus 1. You are not just squaring both terms. You have to actually multiply by itself. Okay. So our last example is a quotient. This time we're dividing. And remember, the rules with dividing is you divide the coefficients and you subtract the exponents. Remember, r is just r to the 1 power, so we're going to subtract 1 from each of these r's. So 10 divided by 10 is 1, and that becomes r to the 5th. 30 divided by 10 becomes 3, r to the 4th, and then 1r to the 3rd. And that's our finished answer. So that is everything to do with the polynomials in our lessons. Good luck with practice and application.